Hey mathematicians, here are your notes for 13.3 day 2, trig functions of general angles. So let's just first review the idea of a reference angle. So the reference angle, remember, is the angle created when we drop a perpendicular from our terminal side. So if our original angle theta is 135, we're going to create that angle, and then wherever our terminal side lies, we're going to find the nearest x-axis and drop a perpendicular. From there, we can label our sides and find our trig functions. Let's go ahead now and jump into the idea of the unit circle. And this is kind of my idea of pulling all of the ingredients from the previous lessons back together. This is where it's going to start to make more sense as an entire idea. So I have the unit circle, and the unit circle is really important because we know that the radius of the unit circle is always 1. Now, if I create a theta angle, and I'm just going to go ahead and create one in the first quadrant, something does change. Instead of the radius being here, remember when he dropped our perpendicular, that this kind of cuts that line off. So this length is no longer 1. Now the hypotenuse is 1 because that's the radius of the circle. But have no fear, we still know what these side lengths are. To get to this point, we go out x and up y. So if I want to talk about theta in terms of its side lengths or in terms of my trigonometric ratios, I can still do that. For example, sine of theta is going to be opposite over hypotenuse, which in this case is y over 1. However, it simplifies to just y because the radius of our unit circle is always 1. The same holds for cosine of theta. If I talk about adjacent over hypotenuse, I get x over 1 or just x. Meaning, instead of having x comma y as my point, if I know x and y, I also technically know the cosine of theta and the sine of theta for whatever angle is on my unit circle. Now, tangent of theta is also there. It's just a little less obvious. Opposite over adjacent would be y over x, or based on what we just learned, sine of theta divided by cosine of theta. Now, this is going to be really important. Go ahead and put a star next to it because we're going to come back to that and need that. We're also going to want to remember that our x on our unit circle is always cosine of theta and our y is always sine of theta. These relationships are going to help us. So now what I have here is the first quadrant of the unit circle. And I have the 5 angles that we talk about when we use the unit circle: 0 degrees, 30 degrees, 45, 60, and 90. Now these are awesome angles specifically because we already know all of the relationships for them. We did that in our previous lesson. So as long as you remember the ratios that these occur in, you are good to go. If you don't, let's do a little reminder here. Remember for my 30, 60, 90, it's going to be x times root 3, 2x. And for my 45, 45, 90, it's going to be x root 2. So let's go ahead and find those 3 trigonometric functions for our basic 30-degree angle. I'm going to create my terminal side here. There's my reference angle theta. I'm going to drop my perpendicular. And just like I did up above, I know that this side length is x, I know that this side length is y, and I know that the radius is always 1. So now if I go ahead and take this triangle off the circle, I'm just going to draw it over here so we can look at it. You've got a 30 degree. Remember that your reference triangles, this isn't quite the same because notice my side length is 1 here and it's 1 over there. I'm just redrawing those triangles for you to remember. If we go ahead and compare this and use that ratio from before, or this proportionality, we can go ahead and say that the 30 degrees instead of having a side length 1 over here, has, this should not be root 2. This should just be 2. My apologies for that. If we scale it down, we have 1/2 and 1, so that we have the proper radius there, and then root 3 over 2. And I just did this by dividing everybody on this lower triangle by 2, so that my radius from my reference triangle is now 1. That's a lot easier to use because these two triangles match. All right, and as I said before, let's use that. Sine of theta, which in this case is 30, is still equal to my y, or as I see here, 1/2. My cosine of theta is equal to my x, or as I see on my triangle here, root 3 divided by 2. So cosine of theta equals x and sine of theta equals y. So my coordinate point for 30 degrees on Radian Man is going to be equal to root 3 over 2. And we're going to put Radian Man together a little bit later, but this is just a reminder that we're going to go ahead and put him on there. But I do want to finish these notes first, so let's flip over to the back. We'll get to these other ideas when we jump over to Radian Man. Before we do that, let's talk about what happens when a terminal ray ends up on an axis. For example, what is sine of 90 degrees, or what is cosine of pi? Well, a quadrant angle has its terminal side coinciding with a coordinate axis, meaning it falls on an axis. The trigonometric value for such an axis can be determined by the coordinates of the point. So this is really big fancy way of saying we know what the points are. If I go out to this point, and this is my initial side and my terminal side, that point is 1, 0. I go out 1 unit and up 0 units. So my cosine for this would be 1 and my sine would be 0. If my terminal side lands on the positive y-axis, I went 0, 1. On the negative x-axis, I went -1, 0. And on the negative y, I went 0, -1. So I now have the cosine and sine for each of these pieces. So let's go ahead and take a look at this chart. Given any of those coordinates, we automatically know the sine, the cosine, and the tangent. Remember that tangent is just sine divided by cosine. But we also know those reciprocal trigonometric functions. If sine is opposite over hypotenuse, then we have 0 over 1, which is okay. But as soon as we try to take the reciprocal, we have 1 divided by 0, which is not okay, making cosecant of 0 degrees undefined. So that table can be useful. You can memorize it if you want. I think there are faster and better ways of remembering these, and the primary one is just knowing what these points are and being able to graph them on the unit circle. Because if you can find the 3 basic trigonometric functions, it's not a far leap to be able to find the reciprocals. But let's go ahead and look at an example of why this information is useful. Suppose theta is an angle in standard position whose terminal side is in quadrant 3. All right, it doesn't tell me where in quadrant 3, so I'm just going to go ahead and say it's right about there. And it tells me that secant of theta is -4 over 3. Find the exact values of the remaining 5 trigonometric functions. Well, the first thing is I don't have a triangle, so I'm going to drop that perpendicular and create a reference angle so that I can do this problem. Secant of theta I know is the reciprocal of cosine, so secant would be hypotenuse over adjacent, making my hypotenuse here 4 and my adjacent side 3. Now you notice I didn't attach the negative yet. I have to attach it to either the 3 or the 4, but not both. And since my hypotenuse always has to be positive and I went in the negative x direction, I can reasonably put together that that adjacent side is -3. go ahead and use your Pythagorean theorem to get the final side. You're going to find that it is negative root 7. From there, let's put what we know back together. Sine of theta, reference angle, opposite over hypotenuse. Cosine of theta should be my reciprocal from here, but let's check ourselves. Adjacent over hypotenuse. It is. We set up our circle correctly. We know that based on this function. Tangent of theta is opposite over adjacent. You got a negative divided by negative, which is just a positive. And then let's do those reciprocals. Remember, no two cos go together. Sine goes with cosecant. I get 4 root 7 over 7 with a negative in front. Cosine goes with secant. That would be negative 4 over 3, which we already knew from our problem. And then finally, cotangent. Flip that 3 over root 7. When we rationalize, 3 root 7 divided by 7. All right, check out that next video for Radian Man. We're going to be putting it all back together. Let me know if you have any questions.